When any substance is exposed to heat, it undergoes significant changes due to heat energy. Expansion of a substance, known as thermal expansion, is one of the important effects of heating. The phenomenon of thermal expansion in liquids is different from the one that happens with the solid materials. In this session, we will study about thermal expansion in liquids. At the end of this session, you will be able to explain the phenomenon of thermal expansion in liquids, describe the practical examples or the applications of thermal expansion in liquids, recognize the peculiarity of thermal expansion of water. How expansion occurs? Expansion occurs on heating as the heat energy increases the moment of the constituent molecules. The molecules collide with and repel each other. This increases the intermolecular spaces. The entire structure is enlarged. The substance occupies more area than earlier, and we say this as expansion of the substance. Liquid and solid expansion differs, as the molecular structures of the liquids and solids are different. They show difference in expansion. Liquids expand more than solid for the same change in temperature. The bonding of molecules in solid is more rigid compared to that in liquids, because of which liquid molecules move freely and rapidly, thereby achieving faster expansion than solids. The intermolecular distances after molecular collisions are more as compared to those in solids, and thus liquids show more expansion than solids for the same change in temperature. Let us see an experiment that shows that expansion of a liquid increases its volume. Take a flask, fill water up to its brim and close it with a rubber stopper. Insert a narrow tube in the flask through the hole of the stopper. Now heat the flask and see what happens. Surprisingly, the water level first drops down and then starts rising. Let's see why this happens. On heating, the heat energy first reaches the solid flask and expands the flask. This increases the width of the flask, and this makes water level to drop down. But soon the heat energy rises the water temperature also, and water starts expanding. The water level rises and we can see the increase in volume of water. Thus, we have learnt expansion in liquid changes the volume of that liquid. Experiment 2. Though it is evident that thermal expansion of liquid changes its volume, the magnitude of expansion changes for different liquids. Let's check this out with an experiment. Take 4 flasks of same size. Fill water in the first flask, liquid ether in the second flask, benzene in the third, and ethanol in the fourth flask. Place all the flasks in a container filled with water and now heat the container. Take flasks. The flasks expand first and the levels of the liquids go down. Later, the liquids start expanding and volume of each liquid is seen as rising with the increase in temperature. The temperature rise for each flask is same. However, the volume increase in all the 4 liquids is different. The ether shows the highest increase in volume. We can say that ether is highly expansive fluid as compared to water and other liquids. Coefficient of thermal expansion. The comparison of expansion in different materials becomes clear with the help of coefficient of thermal expansion. The coefficient of thermal expansion of a material is the value that indicates how much expansion occurs in that material for each degree of temperature increase. For example, coefficient of thermal expansion for ethanol is much higher than that of aluminium, and this shows that ethanol expands more than aluminium when the temperature increase for both of them is same. Liquids in thermometer. The manufacture of mercury and alcohol thermometers is based upon the expansion difference between solids and liquids. Thermometer consists of a glass capillary ending in a bulb shape which is filled with small amount of liquid, either mercury or alcohol, in the form of stained red ethanol. This liquid filled capillary is protected and placed in a calibrated glass tube. As liquids expand at a faster rate than solids, when temperature increases, mercury expands at faster rate than the glass tube. The volume of the mercury increases remarkably for a small rise in temperature. As it flows in a narrow column of a glass capillary, we can see the height of the mercury rising with a little rise in temperature. Thus, thermometers are one of the best applications of liquid thermal expansion. Liquids and engines. Thermal expansion of liquids has an important role in various mechanical engines. Liquids are widely used as a cooling agent or a coolant that cools down engines to lower temperature. Liquids have better thermal conductivity, and their nature to flow helps to carry away excess heat in an engine. In car engines, water or glycol coolants are used to prevent engines from overheating. In nuclear reactors, water or liquid metals like molten sodium or lead bismuth eutectic are used as coolants. Rockets use liquid propellant films to cool their thrust chamber. Anomalous expansion of water. Generally, expansion reduces density of a liquid and contraction makes the liquid denser. When the temperature of water reduces from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, water starts expanding. This irregular behavior of water is termed as anomalous expansion of water. In lakes and seawater, as temperature of the surrounding environment decreases, water contracts and becomes denser and denser until its temperature reaches to 4 degrees Celsius. But water reaches to its maximum density at 4 degrees Celsius and its density does not reduce further. This becomes possible because when the temperature falls down from 4 degrees Celsius till 0 degrees Celsius, instead of contracting, water expands and consequently becomes less dense. At 0 degrees Celsius, the surface layer freezes to its ice, but its density remains lower than the water below it and it floats on the surface. The floating ice also acts as an insulation, preventing the freezing of water below it and allowing aquatic life to survive in water.